A lot of the time when we're using computers now, we're using a computer that is used by basically exclusively us. A lot of the time, we're actually using a computer that looks like this one, and it is used almost entirely by us. But sometimes we're using laptops, and laptops still are kind of just mostly used by us, as opposed to being used by multiple people. We have been using a system that is being used by lots of people and all kind of at the same time. Aviary is a shared resource on the Linux, is a shared Linux system that's used by or available to all computer science students that are registered in courses that are 2000 level or higher. And one of the things that we've got with multi-user systems is this idea that the files that I have in my user directory are not going to be readable by other users that are also using the system at the same time as me. The way that our systems are doing this is by using something called permissions. And permissions are actually used in kind of a few different ways with the stuff that we've got. So we're actually able to read a little bit about permissions or find out about permissions in files by passing a new flag to a command that we've been using a lot in this course so far. So we've been changing directories and listing their contents using cd, but then when we're listing the contents of directories, we've been using this ls command. Ls also takes an option that's -l, so this is a lowercase l, and it will print out the long listing of the contents of a directory. And we get a lot more information about this. The first thing that we get about this is this kind of like opaque and hard to read block of symbols that are R, W, and X and dashes. What comes after that is a number. What comes after that is the username that we have. So my username is fbristow. Your username is going to be something different. On macOS systems, this field here is called the group field, and this is true on Linux systems as well. On my system right now, I'm in a group that's called staff. When you're connected to Aviary as an undergraduate student, you're going to be in a group that's called something like CS under G. The next field here is the size of a file. And now we're going to see that there are directories here and they have sizes, and we will see more about that in Conf 3430 and operating systems. But, traditionally what we see is files, and files have file sizes. There's another number here that is going to be related to the date that this file was created. The format that you see here might be different based on the locale that you're in, but the date of the file represents the time that it was created. And then the last field that we've got here is the name of the file. The thing that we want to focus on right now is actually this first block of characters here. So this is going to list properties or metadata about the file. A lot of the stuff is metadata, but this is metadata about the file related to permissions and the type of file that it is. The first symbol here, this is a D. This says that comp 1002 here is a directory. The first symbol on this entry here is a dash. This is for crazydirectories.tar. Crazydirectories.tar is a file. It's not a directory, it's a file. And so it has this dash symbol. There are other symbols that can appear here, but for the most part, you're going to see dash for files and D for directory. The next block of symbols here, these are the permissions that this file has. And they all appear in this pattern, RWX, RWX, RWX. There might be a dash here to say that it doesn't have that permission. But the structure of this is the first three symbols here are the user's permissions. The next three symbols here are the group's permissions. And the last three symbols here are world or others permissions. What each of these says right now is that for this directory, I have permission, me, Franklin F. Bristow, have permission to read, write, and execute this directory. It says that group users, people who are also in the same group that I am, so in your case, you're in the CS under G group, Other students who are in the same group may have permission to read or execute your directory, possibly. And the last field here is for world or other. So everybody that's logged into the system, they have permission to read and execute this directory. Permissions are hierarchical, so it kind of depends on what the parent's directory is as well. So your parent directory probably has, your user directory probably has RWX for just you, for just the user, and then for nothing else. And then even though these ones have R for group and world, read, because the parent directory is not readable, you won't actually be able to make change into the directories that you've got here. For files, this one here, I have the ability to read and write this as the user, but I do not have permission to execute this file. As a group, you can read this file, but you cannot write or execute this file. And as a world, you have permission to read, but not write or execute. And again, it's kind of this hierarchical structure. So your user directory might not have these permissions. And so this file beneath it technically also doesn't have those permissions. The way that we can actually change permissions is to use a program called chmod. So I'm going to change into the hello directory. This is a directory that had these hello world examples. I'm going to change into this compiled directory. This was one where we had C programs. I'm going to say make hello here. This is just a quick way for me to compile this program without having to do GCC or Clang. When I type ls-l in this directory, what we're going to notice is that hello, this is the program that was compiled, has RWX, RX, and RX. So as a user, I'm able to read, write, and execute this file. That means that I can do, with my text editor, I can edit it. I can say vi hello. It doesn't look like much because this is not a plain text file, but I can write this file and I can quit. I have permission to do that. I also have permission to run this file. I can execute it. So I can say /hello and it will run hello world. I can add or remove permissions from a file using this program that's called chmod, C-H-M-O-D. I'm going to say chmod u-x hello. I want to remove the execute permission from this file for myself, for the user. If I type ls-l here again, then what we can see is that it has no longer got the execute bit or execute permission set for the user part of this. I can remove the execute permission for group by saying g-x hello. And if I do ls-l again, now I no longer have the execute bit set for, or the execute permission set for groups. I can say chmod u-w. I don't want to be allowed to write this file anymore. And now I can just read it. Group can just read it, and world or other can read and execute it. So if I do vi hello hello without the dot, just hello vi hello, and I try to write this now, Vim is going to say that this is a read-only file. It says add exclamation point to override. I can do W and exclamation point, and it will write my file. I don't know how it actually did, but it can. Today I learned something new that we can force write it. I'm going to say chmod a plus x. So I want to add the permission to execute this file for everyone. And I want to add chmod u plus rw. I want to be able to read and write this file as myself. So if I do ls-l here, what I can see is that I've re-added those permissions for myself. Directories have this strange use of the execute permission in that you have to be able to execute a directory to be able to change into it. So if I do chmod a minus x on compiled here, and I try to change into compiled, it will say that I have permission denied. I'm not allowed to change into that. If I do chmod a plus x, so I add back those permissions to compiled, now I have permission to change into that directory. This is kind of a weird use of the execute permission. Permissions really just allow us to be able to specify how a file or folder is allowed to be used by the person who owns it, so us, other people who are using the system. Usually, again, this is masked by the directory that this is all contained within, which is your user directory. This is going to be useful for us when we start to think about looking at how to use the public HTML folder on Aviary to build our own personal website. This is also useful for you in a course like Comp 3010 and Comp 3430, so distributed computing and operating systems, where you start to, one, use the public HTML directory for more than just serving static or plain HTML files. And in operating systems in Comp 3430, we start to learn a little bit more about how file systems actually work.